Today's class, we're talking about networking. So from what I have here, the PDF I have, actually I don't prepare any slides. I just found this slide on one of my drive. Then I just decided to come and use it for you guys. So basically for today's class, we're talking about networking. Like I said in the last, it's very, very essential when it comes to cybersecurity because anything we are doing, we are protecting the cyberspace. So cybersecurity is also networking. We can sometimes call cybersecurity network security because the word cyber means network. Um, yeah, from the table of content I have here, so like the basic concept of networking, like some devices we are used in networking, topologies, how we actually lay out our networking devices. Like last week, I talked about the TCP and the IP model, and also the OSI model. Then, if time permits, yes, I have the OSI model. Yeah. Then, if time permits, um, we talk about the IP address in full, like, but I'm not very sure if we can have the time to talk about the IP address in full. But I'll try as much as possible to explain in terms so that you can all understand it. Yeah. So and after the OSI, that is the last part, which is the OSI, Open System Interconnection Model. So it's networking, networking. The networking we're actually talking about here is computer networking. Like yes, computing networking. It can be a mobile, it can be a laptop, it can be a desktop, it can be other like it can be a phone, it can be a wristwatch, it can be smart glasses, it can be anything that's the networking we're talking about here. So when we talk about networking, so in computing, we can define networking as the connection of two or more devices that communicates over wireless connection. So networking can actually be um,
Please, we are not seeing your computer again.
you know, my screen.
Yes.
I guess share. Can you see it now?
Yes, we can.
All right. So yes, connection like connection of all devices. So it is the connection of my computer and your computer over a wire. It can be a wired connection and it can be a wireless connection. What I mean by a wired connection, in the ancient days, is not even it is still in this 21st century, but when to the year 2010, 2009, cafe to browse. So the connection there is a wide connection. You have more together cafe. So you see those systems that are connected to each other so that they can actually share files or communicate with each other. That is the kind of a wired connection. Then nowadays it is more we normally like we don't actually use the wired connection anymore. We still use it, but it's not as rampant. But now we normally use the wireless connection. You can just stay anywhere and you can connect to a lot of people. You can connect to a lot of devices. You can connect to a lot of laptop, a lot of desktop. So that is it. We have two. It is two terms: the wired and the wireless connection. So the basic concept of network I have here. So normally we have three types, which is actually very common. We have the
Please, your
LAN.
system. Please, we are not seeing your system again. Please.
Sorry, are you? Can is it the only one that can see my screen or another person?
No, it's not the only one. I also can't see your screen.
Me also, I can't see your screen.
Oh, so can you see my screen now?
Yeah, we can see it.
Yes, yes.
Yes, we can see.
All right. So, uh, like I said, we have basic three concepts of networking. We have the LAN, local area network. We have the MAN. We have the WAN, which stands for wide area network, and then we have the MAN, which stands for metropolitan um, area network. So these are the main three that is actually very common. The concepts are very common. The local area network is the one that I just explained that when we, so the LAN, which is the local area network, is commonly used. Like their connection is usually over a wired connection. When we talk about LAN, to local area network, like if you have an hub or you have your you can set up your own devices at home where you have your own personal computer, your child also have his own personal computer. So you can, if you actually wants to share files with each other, you can. That is a local area network, and it is actually used. The connection that is commonly used in a LAN is the wired. So moving down to the next one, we have the WAN, which is the we have the MAN before the WAN, which is the wide area network. So we have the MAN, which is the metropolitan area network. So the MAN, it's more of like a combination of wired and wireless. So because let's say for example, I have my own building, in that same estate, we are living in an estate. In that same estate, I have a friend of mine which we are working in same organization, and we would like to share files for each other because we normally work during the weekend and everything. So then if I actually finish a task, I can send it across to him. We can actually set up a connection between each other. So if we have his own lab at home, if we have his own local area, own apartment, I will also have my own local area in his own apartment. So we can actually connect my own local area network with his own local area network together. So the connection of local area network or modern in a same metropolitan area. What we mean by metropolitan area is in a same, like it is the range of the network will not as long. It's just more of like someone that, okay, let me just use people in as an example. So you are both of you, all of us are in Danbury, but we are living in different apartments. So if we have connection to each other devices through our local area network, that is a MAN. So if you actually wants to extend the connection of Danbury over to both sites, we need what is called WAN, which is the wide area network. So it's more of like wireless connection of MAN together is it's supposed to get um one, which is the wide area network. So those are the kind of those are the three concepts of networking we have. We have the LAN, local area network, we have the MAN, and we have the WAN. So the LAN is basically like is a wired connection, but getting to the MAN and WAN, it is now wireless connection. And then we have this connection does not happen. We have what we actually use to we have devices that will make you that allow us to make or to establish this connection. So these are the devices. So for us to have a connect, like to have a local area network or a metropolitan
Screen.
area network or a wide area network. Can't you see my screen again?
Yes, the screen has gone off. It's not
Yes,
showing
sir,
for
we
me.
can't.
What's now happening today? I guess I shared for all. Coming. Can you see it now? Is the screen accessible now?
Yes, we can see the screen.
So can you see the new tab I clicked now?
Yeah.
How about now? Can you see my screen scrolling?
Yes.
Okay. I guess maybe it's network. So for us to establish, like I was saying, for us to establish all of these um LAN, WAN or MAN establishes, we need devices. If we don't have these devices, we cannot establish all of this connection. So the first devices we need is your own workstation or your own personal PC, because that's what actually what you want to use to send or to share or to communicate with another person's computer. So we need the workstation, and then also we need an orb. Yeah, we need orb. So we need a switch, we need a round. So you can see, like, let me just explain this better. So the orb, we normally use the orb in a local area network. So orb has its own every- let's say for example, in my own apartment, my kids, my mom, my dad, everyone in my own apartment. If you actually want to connect all our personal computers together, and we need a orb. So the orb, there is actually a switch or a port. Yes, it's a port, not a switch. It's a port on your own personal computer where you can actually I don't know what the wire is called because I'm not that deep into networking. So there is this cable that you can actually use to connect your own your own Ethernet to the orb port. So once you connect to the port, your system has been connected to that orb. So you do same thing to your other system that you want to have in the same network. So anything that you want to share, let's say for example, we have so many PC, and this is the port that you can actually connect to. This is the port. So let's say we have five ports here and wants to connect for them to be able to share your resources and information within one another. So you're going to get five cables. So after you get in five cable, you connect your system, your own personal system to the orb. You connect another system to the orb. You connect the five system to the orb. Once you connect everything to the orb, your orb will already understand that, oh, I have five systems that I want to share information with. So whenever you want to, let's say for example, this is PCA. Let's just assume that this is PCB, and they've actually been connected to. But this system wants to send file across to this PC. It needs to communicate with the. And I said, oh, then answer what's up. So I want to share a file to PCB. you actually communicate with the hub first, then the hub will now say, okay, PC now the hub will now establish a connection with PCB that okay, PCB A wants to share a file with you. So before the file actually gets to PCB, the hub will receive it. So the hub is just more of like an intermediary between between the communication like just more of like an intermediary. So before it gets to the hub, then we hub will process the information and send it to PCBs. It is inside the hub that all the connection, like I said, that presentation layer, and there is OS model that I spoke about in the last class. So I'm going to explain the details towards the end of this. So it is inside the hub that everything is the presentation layer, the transport layer, the network layer, and everything. It is inside the hub. But at this point, let's just understand that for a system to actually share information or devices to other system, it needs to connect to that to a hub or a switch or a router. So the hub is for local network, and getting to a switch is more of like a one it's more of like a man metropolitan area network. So it is this switch that after you have a hub in your own apartment, and your friends in Ambari also has hub in his own apartment. So if you want to share information, you need a switch. So the hub, if you want to share information outside this hub, the hub will actually communicate with the switch, and then the switch will communicate with the other hub. So it is the switch that will be an intermediary when in a metropolitan area network. It is the switch that will be an intermediary. So whenever you send a file you want to send a file outside your hub needs to communicate with the other hub. And one powerful thing about switch, the how it was actually built again, is it's have the function of the hub. You don't like nowadays. Once you have a switch, you don't need a hub again, because the all functionality of a hub is inside the switch. So whenever you get a switch, you don't need to get a hub again, because the functionality and everything you need to do the task that you want to perform, you can perform it with a switch. So now going to the wide area network, you need a router. So the router has the capability to communicate, like has the capability to communicate to every other network. So even the internet that we are using, it is the power of router. Let me just give you a scenario. You know, the banking system actually use router to connect to other, they have their own personal branch. Let's say for example the UBA branch in BUK. So they want, like, if you make a deposit in that, deposit to your own, you make the deposit in that bank in BUK. So whenever you want to get your money, you should be able to get your money in that same branch that you deposit. No, the money will reflect across all their branches, because they already have a switch in that branch. So once they have the switch, the information has been saved on that switch. So the information immediately actually connected the switch to a router. So the router will be the one that will not take the information across all other router that UBA branch have across the where they have it. They have it in so many states. They have in all states. So you take it to all the router. They have actually made the connection. So it will take it to all the routers, and then the router will now take it back to all the switch that they have in their local branch. So from there, you see that whenever you made a deposit in Lagos, you can make the withdrawal in anywhere, provided they have their services there. If they don't have their services there, let's say for example, I don't know if UBA have branches in some other African countries, but if you go there is no UBA able to have. But once there is UBA able to have it, and that's the power of the switch, and the router. So we have what is called topology. So topology is just another way of saying the way we connect, like how we make the connection. There are so many. We have the bus, we have the ring, we have the mesh, and so we don't need to emphasize more of the on this because we are not a network engineer. We just want to understand. Okay, this is how they connect computers together for them to be able to share information and resources. Yeah, so this is exactly what we need the most as a cybersecurity enthusiast. We have the TCP IP. These are models. What is a model? A model is just a way in which um, systems or computers share information and devices. You know, we said they share information to the hub. The hub passes it to PCA, send a file to PCB. So the hub is like an intermediary. The switch is the one that was taken. So what is the model? How does this thing happen? That's just the model. But before these things happen, there are some things that is going on underground. So those are the things we'll be explaining in the model. So TCP/IP was developed by the Department of Defense in the United States of America. So we have we have four. Yes, we have four models of the TCP and IP. So we have the application, we have the transport, and then we have the internet work, and then we have the network on its own. So before you send any file across from a single system to another system, before you send, you need what? You need what is called the application. Let's say, for example, you want to share you want a file to a Google Drive. Before you upload the drive to a Google Drive, you need the application, which can be a browser. It can be a dedicated application that was built for that purpose. It can be so many things. So before you do that, you need the application. Yes, because the application is actually is what you are going to use to access or to transfer or to download file over the network. So you need the application. So we normally call it in the OSI mode, the Open System Interconnection, we call it application layer, but in this place we just call it application. So after you get the application, then the transport, this is the next layer, the transport. So what the transport does is, the transport is the one that will tell you that, okay, this is what you want to send, this is how you want to send it. Then the internet work is your own address. Yes, so if you actually, okay, you've accessed the entire the application, you have access to Google Chrome. Then after the Google Chrome, you've uploaded the file. So the process of you transferring the file is called the transport. You transfer the file. After you transfer the file, then they need your address. It can be your IP address or it can be your MAC address, which is the media access control. So it can be your IP. It's even, it cannot even be, it is both your IP address and your MAC address. Then the network is the hub available. So let's see what they have here. So you can see the application layer is exactly what you probably think. It is the layer where the application like Firefox, Opera, email client, or social networking sites, instant messaging. So this is your application that you want to use to share the information. Then after which we go to the transport layer. So yeah, so which kind of connection? So the transport layer is telling you that, okay, which type of connection is this? We have connection, we have the TCP and then the UDP. So the type of connection is the TCP and the UDP. The TCP transport um control protocols. So this protocol is not on the norms they call this connection, this TCP, call it a reliable connection, because even though the network is not good, or the network every file that you are sending over this connection, over this TCP/IP, all files that you are sending across it, it won't be break along the way. It won't get broken along the way. It won't get deleted along the way. Even though your network is not good, it is exactly the way it is on that on where you want to get the information on from the source. Exactly how the information or the data is from the source is exactly how you are going to get it. So we normally you make use of this when we are downloading files. When you are downloading files, if you notice when you are downloading a file, if your network is not good, it will take a long time, but you still get the file you want to download. And if your connection is very fast, you get it very early, you get it on time. So that's the power of TCP. Then we have the UDP, which is the user datagram. So we call it connectionless or unreliable. So it's this UDP is where is the connection where we normally use when we are streaming, live streaming. Like the connection that we are actually using now for this class is UDP. Like as it is now, my screen can be blurred on some people's screen. It's not as if it is blurred from my end. It is not blurred from my end. The data or the screen that I'm actually sharing is very clear from my end. But because of your connection, when you are viewing it, it might be blurred. Sometimes your connection might go. That is why we normally call the UDP the unreliable or connectionless protocol. So we have two types of protocol in the transport layer. We have the TCP and then we have the UDP. You can see, but look for it, it's not just only game. UDP also functions that does not create session. It just shoots a stream of datagrams, like just in a live stream. So it is the connection that you use. So if you are watching YouTube, you can see that at some point it's the video quality will be very low, and at some point the will rise. Even though you said that okay, I want to watch this in HD, even though you set it that you want to watch it in HD, if your connection is not good, you will get a very low quality. And if your connection is very reliable, if your connection is very strong enough, then you get the high reliable. So the interconnect, we have the um, protocol, and then the network access is you have the network access is your internet connection that you want to use to download the file over the internet or across any other platform. You'll be hearing like protocol, like okay, protocol. So they want to explain what protocol is there. So now we are all connected to the internet. Yes, we are all connected to the internet. So for since we are connected to the internet, we are all in this live stream. There is a protocol that brings us to this live stream, to this live class that we are having now. There is a protocol. If the protocol is not there, you don't have a connection. So everything is a protocol. Protocol is more of like an address. Like in an address we normally have okay the block number. For those that stays in estates, we normally have block 7, Dolphin Estate, Ikoyi Lagos, block 8, Bodino Estate. So you see that 8 that is there, a block 8, the figure 8 is just exactly as the protocol. But this one is the case of network now, it's the case of computing now. So you see that 8, block 8, that 8 that is there is just exactly as the protocol. So we have so many protocol. If you want to connect over an HTTP, you need a protocol. If you want to send an email, you can't just send an email. There must be a protocol that will be there. If the protocol is not there, you won't be able to send the email. If you want to download anything from the internet, you need a protocol. So there are so many protocol, and they uses IP address, protocol uses IP address and port numbers. So basically in computing we have 65,000 535 port numbers. Let me check that. Yes, 1000 ports numbers. Okay, let me just say total port number. Total port number. Can see it said 65,535. So on your computer, as it is now, you have 5,535 port numbers. Like if you want to connect to another system, you need these addresses. If you actually want to visit someone, you need to know their what? You need to know their block number. If you don't know their block number, you already know their address that they stay in Dolphin Estate. But you need to know their what? You need to know their block number. So for you to connect to every system, you've already know the IP address that okay, this is my IP address. This is my IP address 192.168.0.5. So this is my IP address. So since you have the IP address, you need to connect to a port. Like you need a port. So you now check these are available ports on a system. You need to know that okay, I need to connect in one of these ports. So if let's just assume that on my system, port 1 is open, but 1 is open. So there is a command in Kali Linux that we can actually use for this, but we still get there. So we have a command called netcat nc. If I said nc, the IP address, and I put port 1, if port 1 is system, if this port 1 is open on my system, it will establish a connection. It will allow your system to connect to my. So, but they said from here, they said from 0 to 1023 ports, it is like companies they used it, like it is just reserved ports. We call them reserved ports. So they are being used by organization, they are being used by top organizations for them to connect to everything. So for them to use it as connection. So if this port 1 is open, it will establish a connection and it will allow you to connect to my system. You'll be able to see everything on my system from your system. So if port 2 is open, but they say port 0 to 1023 is actually reserved. So let's say port 444. You got to understand all of this better as we go on. So port 444 is open. Say NC, and this it will connect if the port is actually open on my system. But on the norms, most of these ports are being closed on our system because if we leave it open, immediately someone else knows our IP. They see our IP address. They can actually NC 192.168.0.1, then the port that is open. So they can actually connect to our system. And once they connect to our system, they will be able to see everything we are doing from their own end. So that is why most of these ports they are closed. Yes, you go ahead and open them on your own. So we have like the application layer have its own protocols. The transport layer has its own protocols. The internet layer also has its own protocols. Yeah, that's for the TCP/IP. So the application layer has its own protocol. So that is what the application layer is. What actually they are part of the reserved ports. They are part of the reserved port. The application layer they are part of the reserved port. So they are part of reserved port numbers. So like the FTP, which is the file transfer protocol, which is used to transfer files between two devices. So the port number is 21. They are no more using 20. 20 is for telnet, but 21, if you said FTP, and you can actually use it like this. You should actually use this FTP. So if you use this command on Linux, Linux knows that this is port 21. And then we have another port number, which is the HTTP or HTTPS. So for you to connect to a web server or for you to access your web, for you to access the web, you need what? the hypertext transfer protocol is either it is in port 80 or port 443. So the port 80 is not secure. Something like this is not secure. And if you say HTTPS is a secure network traffic. So once you are connecting to an HTTP network, everything you are doing there, an attacker can intercept your request and they will see it in a plain text. In a plain text, like everything you are doing, they will see it in they are sending a file to someone, they will see it like clearly, they will see the file clearly. But if you are connecting on HTTPS, is a secure, so everything will be encrypted. Even though the attacker intercepts and they see it, what they will see will not be, it will not have meanings to them. They will just look at it like, what's this? I don't even understand this. So we have another one which is called the SNTP. So SNTP is, if you want to send email addresses, you need the SNTP, like our Google, Gmail, Yahoo Mail, Proton Mail that we normally use. They already open this port SNTP. So if this port is not open, you won't be able to have access to what, you won't be able to have yeah. So if the port is not open, you won't be able to send email addresses. And if this port is not open on the web server you are trying to access, you won't be able to what, you won't be able to access it. So this port actually needs to be open for you to be able to access it. And then we have the DNS, which is domain name service. So the domain name service is just like, let's say for example, let me use Google as an example. If you want to connect to Google, you need google.com, right? Google.com. So this is the Google name, but this is not actually the Google IP address. This is just a name for Google. This is just a name for Google. So the DNS port is the one that will now help you to resolve, because once you are connecting once you are connecting or establishing connection to google.com, in the back side that we are not seeing, it is not actually Google you are actually it is not Google you are connecting to. You are connecting to an IP address. You need to connect to an IP address which can be in form of 192 dot 168 dot 1 dot 5. It can be something like, it will be something like this. So the DNS is the one that will now resolve the IP address. So is that like a domain, like this domain now gets mapped to an IP address, like, and it uses, so it is this port, if this port is open, it is the port that will now resolve to this IP address. And the domain name services is because it is where to remember this. For example, you want to access Google, you type 292.168.13. Access Google the next anytime you want to access, yeah, you need to put down this number. But if you know that okay, this is Google, you can remember the name more than the number. So that is why DNS that helps us to resolve the IP addresses, and it uses port 553, and it's a UDP connection. So for the transport layer, like I said earlier, we have the TCP and the UDP. I've actually explained it. So there are two main protocols used by transport layer to transfer data. Like if you want to transfer data, it's either you transfer data through the TCP. So if you want to upload also, if you are uploading also, it's used, most of upload actually use TCP. While if you are streaming, it uses UDP. And then we have the internet layer protocol, which is the IP address, or yes, internet protocol. So for you to connect any computer, to know the IP address. If you don't know the IP address, you won't be able to connect to the computer. So so the main protocol is what? The main protocols on IP address is the ICMP, Internet Control Management Protocol. It is called the ping. Let me just open my terminal here. Okay, let me use. Can you see my screen, please?
No, sir, the screen is not easy.
You said
It's not busy.
busy. You can't see my screen.
Yes.
You can see your screen, sir.
All right, thank you. So let me just, I'll use both Windows and so the ping command. If I said IP config, so I can see my IP address for my Windows machine. You can see. So for me to know this, I can just copy this and I say ping. For me to know that if the IP address is live, you can see. So once you ping an IP address and you get this response, that okay, you reply from 192.168.243.1 32 bits, and you got something like this, so that the IP address is alive, the IP address is active. So if I say ping, let me just ping another IP address. Let me just put this 77. You can see it's even taking time. Could not resolve or to find the host. Please check the name and try again. So the IP address is not active, like it's not active. So if you get something like this, reply form shows that the IP address is active. Let me use that on my Kali also. Ping. So I have this IP address here. If I ping it, it's actually wants to ping it for me. Can see now that it's taking time. So that shows that the IP address is not active. So if I said ifconfig for me to check my IP address. Okay, this is my IP address on my Kali, and I said ping. You can see that it's active. You can see I got a nice response. If you got 64 bytes from this, shows that, or you got 32 bytes, shows that the IP address is active. So that is the ICMP, Internet Control Management Protocol. So that's the ICMP. So you can see most of the ports, um, ports and the protocols and their ports. We have the FTP, which uses 21, SSH uses 22, Telnet uses 23, HTTP, then SSL and TLS, which uses 443. So we have the IP version 4, and then we have the IP version 6. So these are things like the IP address that I said, okay, this IP address that I have here, 192.168.0.1. This is an IP address. This is what an IP address, and this IP address is a IP address version 4. That is why we have IPv4, IP version 4. So IP version 4 is just constituting, it's 32 bits in divided in the 4 in a 48-bit octet. What that means is, you see, each and every IP address that we have, this 92, it's a 34 bits. 168 is 34 bits. um 0 is 34 bits, and 1, that is why we now have it in what, in 4 octets: octet 1, octet 2, octet 3, and octet. So the dot is the one that is denoting the octet. So we have 192, which is the octet 1, 168 octet 2, 0 octet 3, and then 1, which is and each is consisting of 32 bits. That is what they said here. So if we now say that, so since they are consisting of 32 bits, so 2 raised to the power 32 will give us 4 point, yeah, it is 4,200,000 and something IP addresses. So we just have 4 million plus IP addresses. Is it 4 million or 4 billion? This is 4 billion, right? Can someone help me to do the maths? Come in. 2 raised to the power 32. It is 4 billion. So we have 4 billion IP addresses. And if we check, the devices that we have globally is even more than 4 billion. So how are they now even getting IP address, assigning IP address to other devices? That is being done by what? By subnetting. And then we have just 4 classes of IP. We have class A, and then we have, so the class A is starting from 10 to 10, and have much. I don't know if it's many yet, so the gen is not even on 9 went off. So I knew from IP address on Monday, because I don't want we need to emphasize more on the IP address. Just know that for now we have IP address, and IP address consists of 32 bits, which are divided into 4 8. So 4 8 bits in 4 octets, like I did here, which is 192 1 octet, 168 another octet, 0 another octet, then 1 another octet. So by next class, we talk about the classes of IP address and how you can understand that, okay, this is class A, this is class B, this is this is how they do coordinating. You know, I said we have 4 billion IP addresses, and these 4 billion IP addresses, we have over devices we have nowadays is even over 4 billion. Imagine I have my phone, it has its own IP address. I have my laptop, it has its own IP address. Even if I check my Kali here, it has its own IP address. So you can see that we have even trillions of devices. So how is it possible that it is only 4 billion IP addresses and they still keep generating IP addresses for other systems? So that is the work of subnetting. So we get to discuss that on Monday before we move down to um, Linux. They actually explain everything. I will share this PDF for you guys so that you can have an overview before the class. So I think that will be the end for today's class.